today's problem from particle dynamics, and particularly this is a problem of central orbit or central force. The first part of the problem is very common. Define central force. Okay, we write here the definition of central force. We know that a force whose line of action always passes through a fixed point is said to be central force. Okay, here we draw a rough sketch of central force. Let the central force be F. This is the central force, and the line of action is along the radius vector, and this is passes through the fixed point O, and the particle under this central force makes a path. This is said to be central orbit. Okay, and the force which passes through the fixed point, this is said to be central or center of force. Okay, this is center of force, this is central force, and this is the central orbit. Right. Now the second problem is very interesting and very important. What is the problem? Whether the principle of conservation of energy is hold or not for the motion under the central force. Okay, that is, we have to show the central force is conservative or not. Okay, so show central force is conservative or not. We have to find this problem. Okay, now to show a force field is conservative, we have to show the kinetic energy, that is EK, this is kinetic energy, and the potential energy EP, this is potential energy, this is a constant. Okay, so we have to find the kinetic energy and potential energy of the central force in any central force field, and we have to show the sum of these two energy is equal to C. There be another process to find a force field is conservative. What is the definition of conservative force field? If a force field is such that the work done of moving from a point A to a point B is independent to the path AB. Okay, then we say that this force field is also conservative. That is, if we go from the point A to the point B in different line, that is along the line this, or that is along the line this, or that is along the line this, then in all the lines, if the work done to go from A to B are all equal or all constant, then we say that this force field is conservative. Okay, that is, if we have to find the scalar potential, or if we have to able to find the scalar potential of the field, then this result is obvious. That is, if we find a scalar potential of the force field, then we say that the force field is also conservative. Right? And now a central force F, we know that this is a function of R, let it be F of R. And since the direction of R along the radius vector, so we take here R cap. This is R cap be the unit vector along the radius vector. Okay, now this relation is also be written as F of R into R vector by mod R vector, because we know that R vector by mod R vector, this is unit vector, right? And here we write this is r vector, and the modulus of r we write here only r. Okay, so this relation becomes f of r into r vector by r. Okay, now f dot d r vector, this is equal to f of r into r vector by r dot dr vector. Okay, we know that this r, that is the mod r, we write here r. This is given by root under x square plus y square plus z square, because the r vector is the position vector of any point. This is xi plus yj plus z. So we get r square, this is equal to x square plus y square plus z square, and get the relation as 2r del r by del x. This is 2x, so del r by del x, this is equal to x by r. Similarly, del r by del y, this is equal to y by r, and del r by del z, this is equal to z by r. Okay, now we use here the relation of total differential equation or total differentiation, and this gives dr. What is dr? Dr means, sorry, this is dr. This is the scalar quantity small r. Dr means del r by del x into dx plus del r by del y into dy plus del r by del z into dz, right? And we put the value of del r by del x, del r by del y, and del r by del z from these three relations, and get this is x into dx by r plus y into dy by r plus z into dz by r. Okay, and we multiply the r in the left side, we get r dr. Both the r and r are scalar quantity, these are. And in the right side, we can write this is x dx plus y dy plus z dz. So this is xi plus yj plus zk dot I dx, sorry, dxi plus dyj plus dz, and this relation can be written as r vector dot dr vector. Okay, so we prove that r vector into dr vector, this is r dr. Now we put the value here, f of r by r we write, and the upper term is r vector dot dr vector. So we put here r dr. Okay, because r vector dot dr vector is r dr, we already proved here, and this is f of r into dr, because we cancel out both r, these two are the scalar quantity. Now we take integrate on both sides easily and get integration f dot dr. This is integration f r dr. Okay, now what is this integration? If we integrate the force into displacement, this is force, this is F central force, and this is dr. Dr means small displacement along the tangent. Okay, so this must be the work done. In this integration, if we take the range of the integration is r0 to any point r. Okay, r0 to r. Let this point is r0. This is the zero position. Zero position or zero configuration. Okay, and this is any position, this is P, sorry, this is P, this is R. So by integrating R0 to R, we get the potential energy stored in the particle at P by the central force F. So we get here, this is minus V. Okay, so we get V, this is equal to minus integration R0 to R F of R dr. That is, we get the potential energy or scalar potential of this force field or the central force field. So we say that the central force field must be conservative, right? And to write this relation, we already get the scalar potential or potential energy. This is known as EP. We know that the velocity expression in central force as v square, this is equal to h square into u square plus du d theta whole square. And if m be the mass of the particle, then we know that the kinetic energy or Ek is given by half m v square, and we put here the value of v square and value of Ep. Here we get the conservation equation, and this gives half m into h square into u square plus du d theta whole square minus the value of v is integration r0 to r fr, this is fr dr, this is equal to c, and this is the conservation equation or energy conservation equation in central orbit, and we say that the central force field must be conservative. Okay, thank you for watching.